the strings behave just like lists in almost every way. So if you've got a string, so let's call this one S, some really important stuff in there.
Screen.
You can't see my screen. Hold on.
No.
Let's try again. I thought that might have been why I couldn't open it. So
you got to try, don't you? Yep,
yeah.
We're good. We're up.
Well, it's Microsoft, so like it could be I've got to work, or and if I call IT services, they'll just go, well, "Have you tried restarting?" I'm like, well, no, don't like restarting. Anyway, sorry. So now's not the time for that. Right. So there's my string, just called S. I can use S0 to get the first character. I can use S-1 to get the last one. I can use S from 4 to 9 to get bits in the middle. So I can do all those sorts of things that we had before. I can even do that's confusing, but like K in S, to see if there's a letter in there. I can look for contents of substrings, see if they're in there. So that one's in there, but it said it's not. So it's just like using a sequence in many ways. What I can't do though, and this is probably the biggest difference, is I can't do. Okay, so strings are like tuples in that they're immutable, right? So you can't change one. If you want to change one, you have to actually just make a new one. So when you concatenate strings, for example, you might say this plus that. That's fine, but it doesn't change the two strings. So if we've got S and let's say T is equal to another string, we can then say U is equal to S plus T. So U, S, T. All we've done is make a new one. And we can also do things like say S equals S plus G's. Not a problem, which looks like we're changing it, but we're not, because S equals S plus G's, it evaluates this, and then it creates a new string from S plus G's, and it overwrites S, if you like. It replaces what's it stored in S. So it hasn't changed the string that was in S. S is now just pointing to a different string. So when we do things like S plus equals this, that's fine. Okay, so we can concatenate and extend the string as much as we want. Okay, that's the stuff here. We can do the iteration, we do all those things. We also can do split. So a couple of examples here that I'm going to show you, because I want to make sure you saw some variation. So here's a string 1, 2, 3, 4, and then we can put dot split on the end, and what we want to split with, in this case, is space, and it creates a list of the strings broken up by that. Now there I'm using spaces, and I've got the string written out explicitly. But if I've got things like S, I said, right, S has actually got some slashes in it. Let's do S dot split on the slash, because backslash n and things like that is a special character. So if you want to slash in a string, backslash two slashes. I should have thought about that in advance and used forward, save the complication, but look, we've learned something new. And you can see I now get this stuff, then this, and then this. So it breaks into 3 parts. And that's really common. Like if you've got, I'll show you something quickly. So input os.cwd. What is it? CWD. What is it? Is a get CWD, right? os.getCWD tells me where I am in the file system at the moment. So I can take that, it's a string, the output is a string, and split on that, and now I've got the components of that path. Yeah, so I can see which directions I'm in. The first one's empty because that first slash appears there, so there was nothing before it. So it doesn't just remove it, discard it. It actually, still exists as a 0 length string that comes before it. So there we go. That's split. It's very handy. We can also join things back together. So here, but the interpreter can't handle it very well, unfortunately. Python can use Unicode. Let's see if different terminal works. it's just the font and terminal I'm using there. So that's interesting. So what we're doing is we're taking a string and we're joining it with some of the string. Now you could do it like this. So it puts the bar in between.
The example that I had once upon a time in my programming stuff was banana. You know, it was banana without any A's, and then you dot join it with A's.
So that be
and you end up with a banana.
A dot join
Yeah.
B N N B N N.
Yep. Yep.
No, but then we're gonna have a banana.
You banana.
We could do it the way around. You could join an N. That would probably work with it easier.
That probably works better actually. Yeah, it might have been that way around. Is it?
Yeah. No. Another A. Banana. Banana. No. Let's do it. Let's do it with ba. Banana. There we go. So you can see you can join the sequences. Notice I also did it here. I did it between every letter. Okay, so again, strings acting like sequences. You know, you can do things like that. So there it is. There's the example there. You can also, if you wanted to, you know, sort of split on different things and join on different things. So you've seen up here we've got Python, and then we put multi-line things in between. That all works fine. Another useful thing is strip. So quite often we take input from a user. So we might say something like A equals input, enter your name, and then they go, James space, because users, right? That's just the kind of thing that they do. And then you've got a load of spaces on the end of it. And so if you were doing things like classic, sorry. As soon as I start writing anything, anything in C or C++, as soon as I get back to Python, the print with the F after the brackets is just very difficult for me. And so you see the problem. We end up with that space, because it's part of the string, is there, and we don't want it to be. So what we can do is we can use, so that's A dot strip this. So it filters out the white space. The other time this comes up a lot is if you open stuff from files. So we haven't done files yet, so I'm going to just rattle through that and don't worry about it. But just to give you an example of the problem, let's open up my .emacs. Okay, you can see there's a bunch of stuff that's in the .emacs. If you look at each of those, it's a list of things. Each line is from there. If you look at each line, it's got a /n on the end of it. That's a blank line because it's nothing but a /n. So if I did lines 0, and then I wanted to print it, end up with an extra space, extra vertical space, another line after it, and that's because it's got that new line on the end. The other thing is, if I was looking for, is there a line in there that is require package, but it turns out, that's got a new line on the end, or someone left a space at the start or at the end, it would still be valid config file for Emacs, but it wouldn't be easy to match. Well, that's where I would do the dot strip. Okay, gets rid of the new line. So that's really handy in lots of situations. This one's going to be very, very useful next week when we start on brute force. So here's how we replace something in a string. So here we've got a string on the left, and I'm going to replace all the E's with 3's. Okay, so you can see, no problem at all. Of course, that's showing it all, without any variables, it's doing it with literals, but we could actually do something like, you know, passwords equals swordfish, and then we could do there's no E in swordfish, so very silly. There we go. Okay, replace this, and we could maybe do that again. The other one. So you can see how you can replace things. If we wanted to do both of those things, then what you do is you just use password leet.replace. So you can replace and overwrite the previous one. So password leet is password leet.replace. So we can update the stuff that's there. Very useful. Other things that are useful, and at first I might not seem it, is upper and lower. So if I said, you know, password.upper, I get returned back the uppercase version. Remember, we can't change strings, so all of these return a new string with the operation done to it. Password hasn't changed, but the return from this has changed. So if I wanted to change it to uppercase, I would have to say password equals password.upper. Okay, and now password has been overwritten by a new one. We have lower as well. I can see what it is now. Back to lowercase. This might seem like it's all about display, but it's actually also really useful. Let's say if you were checking to see if a user had typed in, you know, quit. Okay, so you could go if user, so the user input okay, well, yeah, it says capital quit. So maybe we type it like this, but to be honest, most people would probably type it like that. You'll get some people that will, you know, type it like this because, yeah, they're used to typing in sentence case, and there's always going to be someone that's going to type it like this. Okay. Actually, the person that types like that is probably the cybersecurity person, just seeing what happens, because it's interesting to see what things do if you give them funny inputs. But it means that any code that comes later, like where it might say if user is equal to quit, is no longer useful. Okay, so we can say just to test whether it's equal, we can just put this in. No, that's false. And so we'd have to have a check for this before we find it. And so our if statement could end up looking like if user is equal to quit, or user is equal to quit, and clearly that's not what we want to do. So what we'd do instead is you'd say if user.upper is equal to quit. Okay. So if we just look at that as a Boolean, yep, that's equal to true, and we can even just replace this bit to try stuff out. So we can try all lowercase. Yep, that still works. Yep, that still works. And even better, we can combine this stuff. And now
you need the
brackets,
circle brackets. Yeah.
Circle brackets. So we can check to see if it's got quit as the only actual text, regardless of whether there's spaces around it, and regardless of whether it's upper or lowercase. So it's actually really useful for stuff like that too. Last couple of little bits on here. We've done concatenating already, but searching, so we can do the same things that we did before. So you saw that, but we can also use index. So you've seen in, so let's say J in S, J in S, but there's no Q. We can also say, if we know there is a J, we can say s.index. Okay, and it finds the first location of J. Okay. Showing you this. Two things. Firstly, you can also say s.index to get help on just that function. And the reason I'm showing you the help on this function is if you needed to, you can also tell it where to start looking. So if you had to find every one of them and go, okay, we found that one, but I think there might be more, I could say, well, let's start at 4 this time. Sorry, wrong one. Start at 4 this time. Okay, yeah, there was one at 4, so that was the number. Now start at 5, well, the next one's at 7, so let's start at 8. Next one's at 14. Let's start at 15. This one at 28, so let's try starting from 29, and now there are none left. Okay, so you can go through and step along that way as well. Okay,